when the grocery store opens, there are 50 pounds of bananas on the display table. So we have an initial condition. Yeah. So note that there is an initial condition. Then customers remove the bananas at that rate. And then, it gives us the units pounds per hour. And then it says 3 hours later, they start adding bananas back to the table at this other rate from 3 to 12, right? Also in pounds per hour. So first thing is part A, how many pounds of bananas are removed during the first 2 hours that the store is open? So in order to figure that out, all you have to do is what? You need to integrate from 0 to 2, your rate f of t at which the bananas are being removed from the table. And yeah, I had pulled up the scoring guidelines so that I could tell you immediately. And then I put away my phone. Looks like that's 20.051. Yeah. That was a very easy 2 points, I hope. 1 point for the right setup, 1 point for the right number. Everybody good with that? Question? Yep. Yep, probably something. Yeah, I don't know what, but yeah. And unfortunately, they'd probably only give you 1 of the 2 points. Yeah, they usually give you like a 1/1000th leeway on either side of the decimal on the 3 decimals. Usually, like sometimes on here, like for part B, it says, find f prime of 7. Well, to find f prime of 7, you're just going to use your calculator for that, right? You'll literally just write f prime of 7 equals, and on their scoring guidelines, they say negative 8.120 or negative 8.119. So they give you a 1/1000th leeway on that. And, yeah, so f prime of 7, negative 8.120. And then it asks you for the units, right? The units, yeah, using correct units, and it says to explain the meaning of that. And so this is the derivative of something that's already a rate. So that's telling us that the rate at which the bananas are being removed, the rate at which they're being removed is decreasing. We know it's decreasing because the derivative of it is negative. So the derivative of the rate is negative, which means that the rate is decreasing. So the rate at which bananas are removed is decreasing at negative 8.120. And what should your units be here? Should be pounds per hour, or pounds per hour squared would be fine also. Pounds per hour. Everybody good at home with that? Zoom, are you good with that?
Yeah.
Yeah. Everybody here is good with that? Yeah. Okay. Part C says, is the number of pounds of bananas on the display table increasing or decreasing at t equals 5? So if we want to know if the number of pounds of bananas on the table is increasing or decreasing, we have to write an equation that represents the number of pounds that are on the table at any given time, right? So let's first write the equation to represent the number of pounds on the table. So that should be the number of pounds that were originally on the table, right? Which was 50. And then we should subtract the rate at which they're being removed, the integral of that. So the integral from 0 to t, that was f of t, I believe, is that right? And then they start putting some on, right? They start putting them on at t equals 3. And so we need to integrate g of t from 3 to t. I'll write g of x. F of x, just to change the variable so I don't have an x and I don't have t's in both the limits and inside the integral. So that's our function that represents the number of pounds of bananas on the table. We want to figure out if that is increasing or decreasing at 5, so we take its derivative. The derivative of this ought to be what? This is the amount that are removed. Yeah, you probably wrote it G minus F. Yeah. If you did 50 plus the integral of G minus the integral of F, that's fine too. Yeah. So here we've got negative F of t plus G of t, if we take the derivative of that. And so all we have to do is figure out if G of 5 minus F of 5 is positive or negative. And so according to this formula, G of 5 minus F of 5 is negative 2.263103. That's less than 0. Therefore, the number of pounds of bananas on the table is decreasing, because we'll just say the rate is negative. The rate of change is negative. Or the derivative of the function that represents the number of pounds is negative, or there's a lot of different ways you can explain it. That makes sense, everyone? Zoom, are you good with that?
Yeah.
Wonderful. All right, and then part D, how many pounds of bananas are on the display table at t equals 8? So that one should be pretty easy now that we have written an equation to represent the number of pounds of bananas on the table at any given time. All we have to do is evaluate this equation when t is 8. So that's our integral is 50 minus the integral from 0 to 8 of f plus the integral from 3 to 8. Oh, sorry, of g. I don't know why I wrote f again. Of g, and then get an answer. And it looks like that answer is 23.347 pounds of bananas. And as far as points go, for part C, that was worth 2 points. One if you looked at G of 5 and F of 5 at all, and then 1 point for your answer with your reasoning. So 1 point here, 1 point here. And then for part D, that was actually worth 3 points. They gave you 2 points if you set this integral up correctly, and then 1 point for the final answer. So making sure that you remembered to include the initial condition. Which, if you forgot the initial condition, you'd end up with a negative number of pounds of bananas on the table, which doesn't really make a lot of sense. Everybody good there with that one? Oh, did I not tell you guys for B? For B, it was 1 point for this value, and then 1 point for your explanation. So 2, 2, 2, and then 3 for the last one. Everybody good there? Any questions on the banana problem? Everyone's good? Zoom, you're all good? Are you all even there? Anybody paying attention?
Wait, Batch?
Oh, yeah.
For C, how come you didn't need to integrate, like use that like 50 minus, but for D you did?
C is asking if the number of pounds on the table is increasing or decreasing. So to determine if something is increasing or decreasing, you take the derivative of the function that represents this thing. So the function that represents number of pounds of bananas is this function right here. So we took the derivative of it, which is this, to find if it's increasing or decreasing. Part D asks us how many pounds are on the table. So it's asking us evaluate this function from C that we took the derivative of to find the actual number of pounds. Does that make sense?
Yeah. Yes.
Perfect. Anybody else? Any other questions? Everyone's good. All right. How'd you guys do with the graph problems? No? What do you mean no? As in no, they weren't good, or no, you didn't do them at all? Because you just struggled, you didn't like them. I told you guys you wouldn't like them, huh? Isn't that what I said? I said you won't like the graph problems. All right, I'm gonna pull up the guidelines for this one too, just so I can tell you. Where is it? A continuous function. How about at home? Did you guys do okay on it at home? No? Okay. That's not the one I want. It doesn't have the scoring guidelines. All right, that's fine. We'll start. I'll find the scoring guidelines in a minute. All right. They give us a bunch of information here. They give us that this is 2 line segments and a quarter of a circle that is centered at 5, 3. They also tell us that this 0.3, 3 minus root 5 is on the graph of f. And then they say the integral from -6 to 5 of f of x dx is 7. Find the value of the integral from -6 to -2. Right. So we know that the integral from some point over here, -6, all the way to positive 5 is 7. We want to know the value from just -6 to -2. Well, the integral from -6 to -2 of a function, sorry. Man, it's fine. We'll say the integral from -6 to -2 of a function, plus the integral from -2 to 5 of a function should be equal to the integral from -6 to 5 of that function. True? That's just kind of one of those original rules that we talked about with integrals. We can, go across this by adding any pieces together to combine together. Yeah. Okay. Everybody good with the setup there for the first one?
Yeah.
Yeah. Okay. So they tell us that -6 to 5 is 7. We want this one. So we need to figure out what the integral from -2 to 5 of f of x is. Well, what is the integral from -2 to 5 of a function? What does that mean? It's the area between the curve and the x-axis, right? So we should be able to go in here. I don't really need that there. I should be able to go in here and just figure out what the area is between the curve and the x-axis from -2 to 5. So this piece, which is above the x-axis, is just a triangle, right? So that should be 1/2 the base times the height. Everyone agree with that? This piece, I'm going to do it in blue here. This piece is below the x-axis, so that needs to be subtracted. It needs to be negative. That should be 1/2 the base, which looks like that base is 3/2, 1.5, times the height, which is 1. And we're going to make that negative. Okay. The next piece that we're looking at here should be this other triangle. That triangle is above the x-axis, so it should be positive. So that should be 1/2 the base, which is again 3/2, and the height, which this time is 3. Everybody good with that? Okay. Now for the last piece of it, we want this. Well, the only way we can find that is by figuring out what the square right here is, and then subtracting. You guys see the yellow, okay? Yeah. And then subtracting that quarter circle. So what's the whole square? Should be 3 by 3, right? So it'd be 9. And then we need to subtract. You guys can't see that yellow, can you, at all? You guys nodded your head the first time I asked if you could see the yellow. How about orange? Is that better? You see the orange? Yeah. So So the whole square is 9, and then we need to subtract from that this quarter circle. Well, a quarter circle would be 1/4 pi times the radius squared. So that would be 9 minus 9 pi over 4. So we just need to add together all of these different pieces here. First piece is 1/2. Then we're going to subtract 3/4. Then we're going to add 9/4. And then we're going to have 9 minus 9 pi over 4. Everybody good with that? So if we add and subtract all this junk together, -3/4 plus 9/4 is 6/4. 6/4 is the same as 3/2. 3/2 and a half would be 4/2, which would be 2. So we end up with 11 minus 9 pi over 4. Everybody agree with that? Everybody okay with that? Zoom, are you okay with that?
Yeah.
Okay. So then we want to know what is the integral from -6 to -2. So we got to take 7. We got to subtract 11 minus 9 pi over 4. So that's going to give us a positive 9 pi over 4, right, when we bring that over, and a minus 4. Everybody good with that? Let's see. I found the guidelines there now. That was worth. I thought I found the scoring guidelines. Oh yeah, I did. There they are. Okay. That was worth 3 points. So 1 point for setting up this like we did. 1 point for correctly finding this. No, not this. For correctly finding this value, the value from -2 to 5, and then 1 point for correctly subtracting. Good? Everybody okay with that? Any questions on part A? Does that make sense how we did that? Did you guys do that part okay and then you struggled with the rest, or was that the part that you were struggling with to start with? Started struggling with that? Does that make sense now? Conceptually what to do? Yeah. People at home in the Zoom, does that make sense or no?
Yeah, it does.
Okay. All right. Next thing we want to do is part B, evaluate the integral from 3 to 5 of 2f prime of x plus 4. Thanks, Mom. What is the integral from 3 to 5 of 2f prime of x plus 4? Well, the integral of 2f prime should just be what's the integral of f prime?
F of,
Right? And what's, if there's a coefficient in front, we just keep the coefficient. So that's 2f of x plus, what's the integral of 4?
4x.
And we're going to evaluate that from 3 to 5. So that should be 2f of 5 plus 20 minus 2f of 3 plus 12. Make sense?
I don't know if this was mentioned, but this is a no calculator, yeah?
This is, yeah, no calculator. If it doesn't say, it's no calculator. Although, and in fact, all these graph ones will be non-calculator. All right. So 2f of 5. So what's f of 5? Well, this is the graph of f. F of 5 is 0. So 2f of 5 is 0. So we have 20 minus 2f of 3. Well, what's f of 3? Ah, they gave it to us, right? So minus 2 times 3 minus root 5. And then minus 12. And so you'll just figure out what that is. That's 20 minus 6. Minus another 12. That should be 20 minus 18. That should be 2. And then minus, and then a negative. So that should be 2 plus 2 root 5. That seem good to everybody? Yeah. That was worth 2 points. 1 if you correctly got this integral, and 1 if you correctly got the answer. Everybody okay with that? Zoom, are you all okay with that?
Yeah.
Yeah. All right. Part C. Find the absolute maximum of G on the interval from -2 to 5. So first thing, especially those of you that were in the review session last night, it's asking for an absolute max on a closed interval. So we need to check not only critical values, but also endpoints. I think I made a big deal about that, right? I've said it a few times, right? So this is a closed interval, absolute max, critical values, and endpoints are where those could occur. So first off, we know we're going to be checking -2. We know we're going to be checking 5. But we also need to check any critical values. So if this is g of x is the integral from -2 to x of f of t dt. Right? Is that right? Yep. Then how do we find the critical values of g? Find a critical value by taking the derivative, which should just be f of x, right? The derivative of the integral from a constant to a variable of some function is just that function in terms of that variable. So g prime is f. So we want to know, when does f of x equal 0, or when is f of x undefined? So if we look back at the graph, is f of x ever undefined between -2 and 5? No, it's defined for all those values. But when does f of x equal 0? And we can ignore -2 and 5 because we know we're going to check those anyway. Looks like it equals 0 at -1 and at 1/2. We all agree with that? So our x values are -1 and 1/2. So we've got 4 different values that we want to check. Okay. Now, one of these we can ignore for sure. I'll talk about why we could have ignored it in a second, but we're going to check all of them first. So we want to know which of these gives the largest actual value. So we need to go back to our original function, g of x, which is the integral from -2 to x of f. So if we want to find g of -2, that's just the integral from -2 to -2 of f, isn't it? What does that equal? 0. True? All right. If we want to find g of -1, that should just be the integral from -2 to -1 of f. Well, if we go back, that's just this first little triangle, isn't it? That's the area underneath the curve from -2 to -1. That was 1/2. So immediately we know that -2, not the max, right? Because we already got a value more than that. Next one we want to check is 1/2. There's a reason we could have just not bothered with 1/2. Because if we were thinking about f as the derivative, f is going from negative to positive, which means at 1/2, the function g is going from decreasing to increasing. So it's actually at a minimum there. And we can tell that because we put in positive area to get to 1/2, and then we're subtracting off 3/4 from that. So we know that this is, since this whole section is below, the value at 1/2 is going to be less than the value at 1 or -1. Does that make sense? But this is a 1/2. This was a -3/4. So 1/2 minus 3/4 is -1/4, and we immediately know that one isn't the max. Good? Okay. And then lastly, we need to find g of 5. G of 5 is the integral from -2 to 5 of f of t dt. And I believe we already found that. The integral from -2 to 5 of f was 11 minus 9 pi over 4. Right? And we would note that 11 minus 9 pi over 4, but even without using a calculator, we should be able to tell that that is more than a half. Right? And just by looking at the graph, we've clearly added in a lot more positive area here than we subtracted off of the negative. So like this is way more than this little piece. So we've definitely gone larger than what we were with just that little triangle. So did it say what is the absolute max? Yeah, find the absolute max. So our absolute max is 11 minus 9 pi over 4, and it occurs at 5. So if you didn't go through and check your endpoints like you're supposed to do for an absolute max on a closed interval, you would have gotten a half as your answer, right? You would have gotten it wrong. So make sure you check the endpoints. Everybody good with that? All right. Zoom, are you all good with that? That was worth 3 points. 1 point for recognizing that G prime is equal to F. 1 point for figuring out that -1 was a possible candidate. So for checking -1, and then 1 point for the correct final answer of 11 minus 9 pi over 4 with some sort of justification. Your justification is as simple as you did all of this work to show that the critical values and the endpoints, the values of each of them, and yours at 5 was the largest. Good? Yeah. I don't know. It depends on what your conceptual justification was.
I mean,
Right. Yeah. I mean, just empirically, by looking at it, yes, it's clear that that's the case, but they want some sort of proof to back it up, not just, I mean, it's obvious, right? If you look at it, that they're adding more in, but they want some concrete calculus-based proof of it, not, well, look at it. That first triangle is little, and that second triangle is also pretty little, and then that third piece is way bigger, right? So then it's not, yeah. Concrete proof. Other questions, anybody? Zoom, you guys still there?
Yeah.
Still here.
Okay, you guys just don't say much, so sometimes I don't know. All right, what was part D? Oh, that's the fun limit to write out. Okay, the limit is x approaches 1 of 10 to the x. I didn't even really look at it. 10 to the x minus 3f prime over f of x. What was it? Minus the inverse tangent? Okay, cool. So we're looking for this limit, which means what's the first thing we should do when you're looking for a limit? Always, 100% of the time. Just substitute that 1 in, right? So this should become 10 to the first, 10, minus 3 times f prime of 1. Right. Well, what's f prime of 1? F prime means the slope of f, right? So if we're looking for the slope of f at 1, well, this is just linear, right? So we can just find the slope at 1. The rise is 1, 2, 3, 4. The run is 2 for that line. So 4 over 2. Slope is just 2. Everybody good with that? And then in the denominator, we have f of 1. Well, let's go back and look at our graph. What's f of 1? It's 1. And then minus the inverse tangent of 1. What's the inverse tangent of 1? Pi over 4. So literally that is your answer. 4 over 1 minus pi over 4. My guess is that was 1 point. Yeah, 1 point. This one's a little surprising. Usually when they throw limits in the pre-response questions, the limit ends up being indeterminate a lot of the time. Clearly, not all of the time. So make sure you plug it in first and check. Right. And my guess is they're banking on people to say, oh, that must be indeterminate because that's what they usually do in the free response questions. And so then they just do L'Hopital's rule with it and get the wrong answer. So make sure you plug in the value first. Everybody good there with part D? 1 point. Yeah. Well, that's good. Are you sick? Do I need to send you away? Are you going to be gone forever? Okay. Yeah, my kids like were sneezing. I'm like, I don't know what to tell you. Like, you still have to go to school, children. Just because there's like pollen in the air doesn't mean that you're going to infect and kill people. All right. This was the second one I asked you guys to do. Is that right? Yeah. Let's see if I can get up the scoring guidelines for this quickly. If not, then we'll just start doing it and I'll figure it out eventually. So we get some more information here. We've got a parabola this time, and then a bunch of linear pieces, right? Piecewise linear from -5 to 3, and then this parabola 2 times x minus 4 squared from 3 to 6. They tell us that f of 1 is 3. We want to find the value of f of -5. And so they're telling us that the oh, that's not what I meant. What happened there? What? Where'd the problem go? Did I delete it? I deleted it. It's back. Where everybody? I've saved it. Okay. They tell us that the graph here, G, is the derivative of f. Right? So G is f prime. We want to find values of f. Well, what does that tell us? That tells us that f is the integral of G. Right? So we are looking for values for area under the curve of G. And we know that at 1, the value is 3. We want to find the value at -5. So that tells us we should be able to write this out and say that f of x could be equal to the integral from 1 to x of g of t dt plus what value? Plus 3, exactly. Okay. Because this way, when I plug in 1, the integral from 1 to 1 of g is 0. I add the 3 to it, that gives me the 3 that I'm looking for. Does that make sense to everybody? Okay. So we want the value of f of -5. F of -5 ought to be the integral from 1 to -5 of g plus 3. And so how are we going to find the integral from 1 to -5? Well, normally we'll go from left to right, and this is right to left, yeah? So we can flip the limits of integration. And if we flip the limits of integration, we flip the sign of it, make it a negative. Integral from -5 to 1 of f of t dt. Everybody good with that? Yes, no, maybe? Yeah? Okay. All right. So what are we doing here? We're looking for the value of f of -5. So, oh, why did I write a g there? I mean an f there. I should have written a g there. Sorry. I don't know why I wrote an f there. It was a g over there. Everybody good with that now? Now that I've written the right variable? Okay. So what's the integral from -5 to 1 of g of t? Well, from -5 to -2, that's just a square. And it's a square that's below the x-axis, so that should be -9. Then from -2 to -1, that's a triangle. It's below, so we're going to do minus, and then it's 1/2 the base, which is 1, times the height, which is 3. And then from 0 to from -1 to 0, it's just plot across the x-axis. So that should be 0. And then how far are we going to? To 1. Then from 0 to 1, it should be 1/2 the base of 1 times the height of 2. So it looks like that gives us a value for the integral from -5 to 1 of -9 minus 3/2 plus 1. So -9 minus 1/2. We combine those together, which ought to be what, -19/2. So we have 3 minus -19/2. 3 minus -19/2 ought to be 13/2. That's not right. I cannot do it. That ought to be 25 pounds. I don't know why. For some reason, I thought that was a negative. Good or no? Any questions there on part A? Let's see how many points that was worth. That was worth 2 points. 1 for finding, let's see, 1 for, it says 1 for integral. I think they're saying 1 for setting this up correctly and then 1 for getting that answer. That's what I think they're saying. I flipped the integral from 1 to -5 to -5 to 1 because we always want the lower limit to be on the bottom and the smaller value to be on the bottom, not the lower limit. The lower limit is always on the bottom. We want the smaller value to be in the lower limit and the larger value to be in the upper limit. And that way we can just integrate from left to right, finding the area. Does that make sense?
Yeah, thank you.
Yep. Everybody good with part A? Okay. Part B, find the integral from 1 to 6 of g of x. Okay, well, all we have to do for that is just find the integral, right? We're just looking for the area underneath the curve from 1 to 6. So we'll do each piece of this separately. The first piece is just this square. That square ought to have an area of 4. And then the second thing that we'll do is we'll do the area underneath this parabola. So we're looking for the integral from 3 to 6 of g of x, right? Well, that's 2 times x minus 4 squared. So the integral from 3 to 6 of 2 times x minus 4 squared. And that should be our answer for B once we evaluate that. So what is the integral of 2 times x minus 4 to the second? You have to do a simple u sub on it, right? Let u equal x minus 4. Du is just dx though. So this really just becomes 2u squared that you're integrating, which should become 2/3 u cubed. So we'll have 4 plus 2/3 u cubed evaluated from 3 to 6. Everybody good with that? So we end up with 4 plus, and we got 2/3 of 8, right? 6 minus 4 is 2, 2 cubed is 8, minus 2/3 of -1 cubed is -1. So we got 16, we got 4 plus 16/3 minus -2/3, so plus another 2/3 gives us 18/3, which is 6, plus the 4 is 10, and that was worth 3 points. 1 point if you split it into 2 different things here, 4 and then this integral from 3 to 6. 1 point if you correctly found the antiderivative of 2 times x minus 4 squared, and 1 point for this final answer. Didn't I answer? I thought I answered that question to everybody, right? I did answer that question. Okay, just making sure. Any questions there on part B? Everyone's good?
Sorry, I might have not heard you say that.
That's fine. If you want to, you can answer people's questions in the chat for me. That's fine. I don't mind. All right. Part C, for the interval from -5 to 6, on what open intervals is the graph of f both increasing and concave up? Okay. So let's see here. Part C, we want f to be increasing and we want f to be concave up. So before we even go back and look at the graph and try and figure this out, what does that mean to us in calculus terms? If f is increasing, that means that the derivative is positive. And if f is concave up, what does that tell us? The second derivative is positive, right? Increasing first derivative positive, concave up, second derivative positive. So now we go back and we think about what we'd already written here. We already said that f prime was g way back at the beginning. So f prime being positive really just means that g is positive. And well, if g is the same as f prime, what is the second derivative of f? That should be the derivative of g. So we want to know when is g positive and when is g's derivative positive. Does that make sense to everybody? Okay. So let me go back. When is g positive? Well, g is positive from 0 to 4, and then from 4 to 6. So really, we can just kind of say 0 to 6. It's probably good enough for now. Right, this is true from 0 to 6. I should put this brackets because that's how they like to put it. And then when is g prime positive? Well, g prime is positive whenever the slope of g is positive. So is the slope of g positive here? Nope, its slope is 0. Is the slope of g positive here? Yeah, do I care about that? No, because that's not between 0 and 6, which is where it was increasing, or where g was positive. What about from 0 to 1? Slope is positive. Okay, so 0 to 1. What about 1 to 3? Nope. What about 3 to 4? Nope. What about 4 to 6? Yes. So the overlap of 0 to 6 and 0 to 1 and 4 to 6 ought to be 0 to 1 and 4 to 6. And it's specified specifically. I guess that's how you specify things, is specifically. They specified open intervals, which you would have to do anyway because we're talking about concave. So 0 to 1 and 4 to 6, that was worth 2 points. 1 point for the intervals and 1 point for some reasoning, being, all this stuff. F prime is positive, so G is positive. F double prime is positive, so G prime is positive. Good there on part C or no? Zoom, you guys good?
Yeah.
Okay. Serena, you good back there? All right. My May 4th people, you're both good on this? Yeah, Leopold, you're good? Good enough? Okay. All right, part D, find the x-coordinate of each point of inflection for f. So if f has a point of inflection, what does that tell you? If f has a point of inflection, f double prime needs to change signs, right? Has to change signs, has to go from positive to negative at a point. Well, if f double prime is changing signs, that means that g prime needs to change signs, because that's what f double prime is g prime. So we just go back in and look at our graph. When does the slope of g change from positive to negative? Well, here's a place where the slope of g changes. It changes from 0 to positive. Is that a change in signs? No. Here's another place where it changes. It changes from positive to 0. Nope. Here's another place. It changes from 0 to positive. Nope. Here's another place. It changes from positive to 0. Nope. Here's another place. Changes from 0 to negative. Nope. Here's another place. It changes from slopes that are negative to slopes that are positive. So only one place is there a point of inflection at x equals 4 as a sign change of f double prime or of g prime. And that was worth 2 points. 1 for the answer, 1 for the reason. How do we feel about that? We feel like we could do better with the graph FRQ questions now that you've seen a couple? At least better than you originally did, which was horribly. Yeah? Perfect. All right, I think that the right thing for us to do is to try to do this next one right now. What do you guys think? Yeah? Seem good? I think so. All right. I'm going to give you guys 15 minutes here to work through this one. And with any luck, we'll be able to get through it. Ready, go. Let's try and work our way through it here. We're looking for f of -6 and f of 5 to start with. Okay? We're given that f of -2 is 7. This is the graph of f prime. So f should be the integral of this. F should be the area underneath the curve. So what we want to do is we want to say that f of x should be equal to the integral from -2 to some x value of f prime plus what? Just like in the last one, we got to add a
7.
7 here this time instead of a 3 last time, right? Because if we plug in -2, it needs to equal 7. All right. So that means that if we want to find f of, well, let's find f of 5 first. Okay? Actually, let's find f of -6 first. If we want to find f of -6, that should be the integral from -2 to -6 of f prime plus 7. So just like in the last one, since this is a larger number in the lower limit and a smaller number in the upper limit, we're going to flip those and make it negative. So this ought to be 7 minus, say that again.
We chose -2 because we are given the thing f of -2 equals 7.
Correct. Yes. Because of the initial condition given to us.
That's the thing that I couldn't think of the word.
Yes, the initial condition is the thing that you, yes, the thing you were talking about. All right, everybody good with that? So 7 minus the integral from -6 to -2 of f prime. Yeah. So what's the integral from -6 to -2 of f prime? Well, it's just that triangle, right? What's that triangle? It is 1/2 the base, which is 4, times the height, which is 2. So we got 7 minus 4. F of -6 is 3. Everybody good with that?
Yeah.
That makes sense now? We feel better now? Yeah? Akash, you go with that? Yeah? Okay. What about f of 5? F of 5 just means we want 7 plus the integral from -2 to 5 of f prime. So that's going to be 7 plus, and let's see here, from -2 to 2, it's a semicircle that is below the x-axis, so that's going to be negative, so I'll put the negative there. And then that semicircle's area is 1/2 pi times the radius of 2 squared. Everybody good with that?
Is that a plus next to the 7 or? Okay.
Yeah, I mean, I put the negative inside there because it's below. You could have just said 7 minus 1/2 of 4 pi. But either way is good. And then we need to add to it this other triangle. This other triangle is a base of 3 and a height of 2. 1/2 of 3 times 2. So we got 7 minus 2 pi plus 3. So f of 5 is 10 minus 2 pi. And I believe it was 1 point for each of those values. I will check. No, 1 point for each of those values, plus 1 point for using the initial condition to properly set it up. So 3 points there for part. Good or no? No? Yeah? Good? Yeah. Everybody good now?
Wait, does that mean if you used like a different method of finding the values, you wouldn't get that point because you didn't use the initial condition? Or can you not do it without the initial condition?
You cannot do it without the initial condition. There's no way to get those values without using the 7 in some way. All right, for part B, when is f increasing? Well, f increases when its derivative is positive. This is the derivative, so its derivative is positive from -6 to -2, and from 2 to, what is that, 5? And I put them in brackets because that's what they say to do for increasing, decreasing intervals on the AP test. And your justification is f prime greater than 0 on those intervals. And that's worth 2 points for that whole thing. Answer of the intervals with your justification is 2 points. Everybody good? Yeah, question? Yep, I mean, yeah, I would say -6 to -2 and 2 to 5 because f prime is greater than 0 on that interval. Something to that effect. They wrote f prime greater than 0 on the intervals, -6 to -2 and 2 to 5, therefore f is increasing on those intervals. But anyway, that's literally all. That's it. All right, part C, find the absolute minimum on the closed interval. So if we're talking about an absolute minimum, that could be at a critical value, or since it's a closed interval, it could be at an endpoint. So we need to check -6, we need to check 5, and we need to check any critical values. So critical values will be when does f prime equal 0. Well, f prime equals 0 here at -2, and f prime equals 0 here at +2. Everybody agree with that? Okay. So we need to check for part C the values at -6, at -2, at 2, and at 5, for which one is the absolute minimum. Well, at -6, we already found that value. That was 3. At -2, we know that value. It was 7. At 2, well, we didn't find that value specifically, but we can get it in a second. At 5, we did find that value. It's 10 minus 2 pi. And then at 2, that was just the integral from -2 to 2. So that was what we got right here before we added that extra triangle piece on at the end. So that's 7 minus that 2 pi. And which of those things is the smallest? Well, looks like 7 minus 2 pi is the smallest, right? Because that's going to be less than 1. This is not less than 1, and this is not less than 1, and this is not less than 1. Everybody good with that on part C? All right. Real quick, we're going to do part D. It's going to take us like 20 seconds. Does f double prime of -5 exist? Yeah, that's the slope of f prime. Right? The slope of f prime. Well, what's the slope of this? It's down 2 over 4, -1/2. And what about at 3? Can the derivative of something exist at a corner? No. So it does not exist. Why? Because it's a corner. And that was worth 2 points. 1 for each of those. So that's part D. If you guys have any questions in the Zoom or here, you're welcome to stay and ask. Otherwise, I guess what's tomorrow? Friday? Tomorrow's Friday, yeah? So I'll see you all in Zoom tomorrow.
What's the quiz on again?
What?
What's the quiz on again?
The quiz is on the area volume and then the differential equation FRQs.
Thank you.
You're welcome. See you all tomorrow in Zoom.